Everyone. I am Sahil Khatri, working as an assistant professor in automobile engineering department. Glad to welcome our today's expert, Mr. Vises Shah, on this webinar on introduction to electric vehicles. Okay, he is currently working as a technical recruiter at Colavera, and he is our PU alumnus, class of 2014. So, by not wasting much time, I directly hand over this session to Mr. Vises. Vises?
Sure. Thanks for inviting me. First of all, I would like to thank you, Sahil sir, as well as our head of the department, that is Shailesh sir, and obviously Parul, that is for sure, for inviting me over here. So yeah, I'll just brief about myself over here. I am Vishesh. Basically, I'm working as a technical recruiter at Collabra. And other than that, I am a person who has been a part of an SAE event, which was conducted like 2 years back. And that event was conducted by SAE, as I said, and it was basically an electric two-wheeler design competition. And for that competition, me and my team were the winner of that competition by winning for best overall performance and best maneuverability as well. So yeah, that's all about me. So I'll just begin the session with the same. So should I begin with the same?
Yes, Vises.
Yeah, sure. So yeah, talking about the same, like as we can already see, just a second. I'm just putting on the presentation. So yeah, this is all about the introduction to vehicles. So yeah, first of all, a clear picture comes into our mind that why electric vehicles, right? Obviously, there are gasoline vehicles going into the market right now, and can already see that government is implementing new policies to like bring electric vehicles into the market. So what is the reason behind that? The first reason, as you can see on the screen, is increasing automobiles, right? I think most of the people who are here must be preferring their own more like four-wheeler or something like that, right? Obviously, we don't like to go for a public transport because it's the conveniency is more in our own vehicles. So that is the only reason that increasing automobiles, declining oil reserves. As you can see, the fuel prices are all-time high. I feel like it's almost 95, 96 right now. The greenhouse emissions, right? Obviously, when a gasoline vehicle or a diesel vehicle is run, it basically leaves out some gases, which are basically, you can say it as CO, that is carbon monoxide, carbon dioxide as well. So basically, they result into some greenhouse emissions as well as the depletion of ozone layer. That is for sure. That is one of the reasons. Global warming, as we can see, greenhouse emissions and global warming. These are the two basic parts, which are, or you can say, basic reasons why people are turning to electric vehicles. And at the end, we can always say that money as well. Like financially, though electric vehicles initially they prove to be a bit, what you can say, a bit all-time high in terms of prices, but at the end, it gives you a lot of savings into the terms of emissions. So yeah. Turning on to the next slide, like what is an electric vehicle? Electric vehicle is a vehicle which usually runs through electrical energy. Now, electrical energy, it can be in terms of any ways, like it can be through batteries. Even some, as of now, we are using electric vehicles which can be run through grid as well, national grid as well. That is also the case. And yeah, the basic reason why electric vehicles are preferred over combustion vehicles, the only reason is that there is no pollution, as we can see on the last slide as well. And other than that, it's a vehicle which usually uses electric energy that is stored in batteries. Okay. And unlike vehicles with combustion gas, electric vehicles do not produce any exhaust gas during operation, as I said. This along makes electric vehicles more environment friendly than the vehicles with conventional technology. Now, as soon as you start using these electrical vehicles, right, the first thing that happens is greenhouse emissions and effects and all of that. The second thing is noise. Electrical vehicle produces noise which is like compared to nothing, like as compared to the conventional vehicles. However, the electrical energy from charging the vehicle does have to be produced from renewable sources, that is from wind, solar, hydroelectric, or biogas power plants. By combining different type of drives, the overall efficiency of the vehicle can be improved and fuel consumption can be reduced. So here we are not going to only talk about only electric vehicles. There is not only battery electric vehicles, but we are also going to be talking about like hybrid electric vehicles. Like other than that, PHEV, that is also one part of a hybrid electric vehicle. and fuel cells as well, which usually uses hydrogen and all of the hydrogen and battery combination to run the vehicle. So these are some basic insights of an electric vehicle. So from this, we can just conclude that the electric vehicle is a vehicle which usually runs through electric motors, which is run by batteries. So running on to the next slide, like how does it work? So talking about the electric vehicle, right? Electric vehicle has got a lot of parts, but the four basic parts that controls the whole electric vehicle, we can see on the screen. It is controller, battery, electric motor, and a charger. Okay, charger though is not an integral part of a vehicle, but yeah, it is a mandate thing for obviously to charge a vehicle. Now I'll just brief somewhat about the same. Like I'll just give an insight regarding the same, and we'll just brief later on with the like what exactly the parts are. So the controller is a like an integral part which usually you can say controls the whole electric vehicle. In normal electric vehicles, we can see that we have got ECU, that is electronic control unit, which usually controls the whole vehicle. But here we have a controller, which controls the power coming from the battery and transfer it to the electric motor. Right. Now, talking about the battery consists of a lot of types. Like there are lithium-ion batteries, lithium phosphate batteries, lead-acid battery that we are using in conventional vehicles right
Vises,
now.
Vises.
Yeah, I'm audible. Yeah.
Sir, can you represent your screen because your slide is not changing?
Sure. Just a second. Just wanna check it.
Okay, Vises. Continue.
Yeah, sure. I think that must be due to some glitches. Right. Sure. Now is it audible? Now is it visible?
Yes, it's visible.
Yeah. So as I said, there are three basic parts, or you can say four basic parts of an electric vehicle, which usually consists of a controller, a battery, and an electric motor. Right. So as I said, the control is an integral unit which usually works same as the ECU in a conventional vehicle. It controls all the power coming from the battery to the electric motor, like in what proportion to give the power to the electric motor. It is decided by the controller. Then battery is an integral part which is usually consisting of different types of that. So one of them is lithium ion, lithium phosphate, nickel cadmium. Then you can say lead acid batteries, right? We'll obviously see about the efficiency of different types of batteries, that is for sure. But yeah, battery is a main and important part of electric vehicle. Then talking about electric motors, like electric motors is the vehicle which usually it can be a hub motor, it can be a synchronous motor as well. So I'll just brief you what is what is the main function of electric motor. Electric motor is a part which usually drives the wheels, right? It can be through a chain drive vehicle, it can be through a belt drive, it can be directly through the wheel drive, that is for sure. So that is the function of electric motor. Now the charger and the charging point. So charger usually depends on what type of proportionate speed do we want to charge the vehicle, right? Talking about the same, like charger, right? A charger can be a big, it can be small. It usually it can be dependent on what type of voltage and ampere we are using for the battery. And the more faster we charge the battery, the more its cell gets destroyed. That is for sure, because we already seen this in the phones as well. Like you're using a mobile phone, right? It usually has a nickel lithium ion battery. So if you are using a latest phone, then you must be knowing that if you use a fast charger, right, what happens? It will charge your phone fast, that is for sure. But at the end, after a couple of years or a couple of months, you can just notice that your battery health is getting spoiled. Like the efficiency, like initially it would be like your battery would run for a day, then it would run for 8 hours, 9 hours. It will usually vary. That is what the function of a charger and a battery. So yeah, coming to the main function of how electric vehicle works. So yeah, how does it work? So initially when we like on the vehicle, right, like we ignite the vehicle. So what happens is, as soon as it like in an electric vehicle, as soon as we are on the electric vehicle, it usually depends on the paddle, right? Like in the, you can say, throttle as well. So as soon as we press the pedal, the controller gathers all the information from the battery and gathers the energy from the battery, like in what proportion to take the battery and how the pedal is pressed, right? That's what it will do. Then depending on how much the pedal is pressed, the controller will decide that how much energy should I give it to the motor, so that it can convert the same into a useful or mechanical energy. Right. So that is what is done. Control relieves the appropriate amount of electrical energy to the motor. The third point, electrical energy transforms to mechanical energy. So that's what we can see. Battery, that is electrical energy, we convert that into a mechanical energy by the terms of controller and the motor. And at the end, as the motor moves, your vehicle moves on the road. That's what we can see. Right. So these are some basic insights of how basically electric vehicle moves. Now coming to the next part, what are the main components of an EV? There are a lot of components. Some components are there as a conventional vehicle as well, like the cooling system and all of that. But yeah, they vary a lot from the conventional vehicles. That is for sure. Like some systems such as the cooling system, then you can say a battery. Our conventional vehicles does not use a BMS, that is battery management system. In this vehicle or electric vehicle, we use a BMS as well. That is the case. We can just go with the parts. The first part is a high voltage battery with a control unit for battery regulation and a charger. So high voltage battery, that in the sums of, like, it can be a 48-volt battery, it can be a 72-volt battery. We can we'll obviously see that what type of battery regulations are there. The second part is the electric motor or generator. As we have seen in the last train, the electric motor is an integral part which usually converts the, you can say that it usually drives the vehicle. So yeah, that is the case. Transmission including the differential. So transmission in the sense, what happens basically, it can be a two-wheel drive, it can be a four-wheel drive as well. And depending on the motor, it usually needs a differential to drive the vehicles. If it's a synchronous motor, we'll be using only one motor to drive all the four wheels. But if it's a hub motor, we won't be needing any differential. The fifth part is the braking system. Braking system remains the same. It will be hydraulic. That is the case. And it will be usually run by the hydraulic, that is oil and all of that. High voltage air conditioning for vehicle interior climate control. Now, come on, as we are living in the 21st century and all of that, so every vehicle uses the electric air conditioning, and that is the case, right? So it's high voltage air conditioning is required, and battery also depends on the same, right? So more, वो कहते हैं ना, that is a term in Gujarati, that jitli sagod etli agod. That is the case. So that is the case. You will be getting a lot of components that you will be using it for. Electric motor or generator, that's what we'll be using. Power electronics. Now, power electronics usually varies on signal lights and all of that. Signal lights, braking lights, that are all power electronics. That usually like the wiper motor and all of that. High voltage lines. Now, if you're using a conventional vehicle, and I think everyone must be aware that a conventional vehicle uses only a 12-volt battery, but during the spark of an engine, it usually converts that same into a 22,000 volt or 20,000 volt for a single spark to happen. So if you can just believe that if in the conventional vehicle, if you are using 22,000 volt and all of that, so you can just remember that amount of power that will be using for the whole electric vehicle to drive. Okay, so that is the case. Then a high voltage battery, as I said, basically battery, mentioning 2 times battery is the only reason that usually battery packs depends on what type of battery we are using. If we basically, one of my colleagues made an electric tractor. In that, he used 2 batteries, depending on one was to drive the vehicle and the second one was to like pull the equipments that are used. So that is why I only mentioned the 2 times battery. That is the only reason. Electronic box with control unit for battery regulation. Now, actually, I have abbreviated this term. Basically, in this term, we are just talking about the PMS system, that is battery management system. The cooling system, as I already said, that obviously if your vehicle is running light, whether it's a mechanical vehicle, like whether it's a mechanical energy or it's any of the energies, your vehicle will be heated by using it. Whether it's, so for that purpose, we are using the cooling system as well. Braking system, high voltage air conditioning compressor. Now, compressor is a part which is the most important part of air conditioning system. You can say that in our vehicles or conventional vehicles as well, 70% of the power of the, you can say, task of the air conditioning is done by the compressor, because it is the only one which is driven by a V-belt drive. That is the case in conventional vehicles. In this case, it is driven by a motor, or you can say it is driven by battery itself. High voltage heating. So yeah, to prevent this high voltage heating and all of that, basically we have a cooling system. That's what is being shown. A battery charger, as I said in the previous slide, that it depends on what type of battery we're using and what type of speed we are requiring to charge the vehicle. Then charging contact for external charging, right? We must be having a socket to charge the vehicles. External charging source, like it could be from the grid and all of that. But as of now, it's not implemented in India yet. In India, we're usually using the power that comes into our home. That is a three-phase lighting to charge our vehicles right now. But in US, that like the vehicles for Tesla and all of that, the technologies have come that where you can directly remove your battery and charge the vehicle. That is the case. Okay. So how did EVs come into the picture? First of all, like how did EV starts? So it's not like EVs have been a part right now, or it used to previously. Like when we started the when human beings started a vehicle, it usually started with the steam engine, right? Now steam engine, you can say it somewhere connects with the electrical energy as well, right? Because in steam energy we are using the same, that we are converting that power into the energy to turn the vehicle, to turn the wheels of the vehicle, and this is the same. So in 1970s, there are some government acts which came into the picture where we were informed that we can use some preliminary techniques to start these electric vehicles. Then in 1988, the GM EVI, the red color which can see on the screen, right? That is a sorry, not that one, the gray one, right? Which we can see the GME, that is General Motors EVI. That was electric vehicle which was used preliminary. Then from 1997 to 2000, a few thousand electric vehicles are produced, but they were on lease. Like people are not purchasing it. The reason behind not purchasing it was the maintenance. The thing is, that time the chemical conformations and all of that were not that into the picture. So it was just some preliminary techniques that the people were using for electric vehicles. So in that phase, 1997 to 2000, a few thousand electric vehicles were only used for available on the lease. People are taking on the lease in US. Then in 2003, GM discontinued the EVI and killed the electric car. Like there was a phase basically, like from 2000 to 2005, there are no electric vehicles at all. Like if you must have noticed some periods, right? The Honda two wheelers and Yo bikes and all of that. Those all came into the picture after 2007 or 2008 by seeing the concept of the GM EVI, because it was the one who implemented the electric vehicle. So yeah, so in that phase of 2003 to 2007, there were no electric vehicles at all. Like they were available, but people are not using it. Seeing on the convenience that we have, because thing is, at those times we were just start having the vehicles like Esteem and all of that, like Esteem. Then you can say that Wagoner and all of that. That's what vehicles came into the picture, right? After that, finally in 2007, company was invented. You can say a main company which is ruling all over the world in terms of electric vehicle, that Tesla. So we can just see in the front of the screen, this is Tesla Roadster, which was the first ever electric vehicle of Tesla. And it basically, in the preliminary days, it also used the same electric batteries that we are using right now in our conventional vehicles. It is a lead acid battery, but they were into the forms of dry conformations, conventions. That was the case. Okay, so this is all about the history of EVs. Now we'll just brief about how about type of electric vehicles. Like types of electric vehicles, there are a lot of type electric vehicles. That is battery electric vehicle, plug-in hybrid electric vehicle, hybrid electric vehicle, and fuel cell electric vehicle. So there are basic conformations of all of these. We'll brief also about this in that is we'll see in the next slide. So yeah, battery electric vehicle. Now a battery electric vehicle is opposite to a conventional vehicle, like a gasoline engine or all of that. So what is exactly a battery electric vehicle? A battery electric vehicle which does not use an internal combustion engine, that is IC engine, and it directly uses your battery power, and which is usually derived from the power grid that we have at our homes. So that is battery electric vehicle. This electricity is stored in both batteries that can run vehicles wheels using one or more electric motors. Now, as I rightly said, motor depends that what type of motor we are using, whether it's a synchronous motor or a hub motor. What should you know about battery electric vehicles? The initial purchase price is significantly higher than compared to gas-powered vehicles. The scenario is same right now as well. But that is the only reason that government is implementing policies that you can just purchase the electrical and it will give you somewhat benefits in terms of prices. Right? It is offered you in province. Demand for battery electric vehicles should result in lower purchase prices in future. That's how the government is doing right now. You can save a lot of money on fuel and maintenance cost. See, I'll just give you an example. Suppose if I have a vehicle, right? If I want to go by a bike to any of the places, and if I want to travel supposedly 75 kilometers, right? So as of now, I can just calculate 5 rupees a kilometer for a normal vehicle right now, on the prices of all time high of 95, right? So that will be costing me something around, you can say calculate around 600 to 650 rupees, right? On the same part, if you are running an electric two-wheeler, though it will give you a lesser speed, but yes, if you can go the same distance at the cost of only 8 or 9 rupees per kilometer. And this is the practical example which I have done so far, right? That is for sure. So that is the only reason that electric vehicles, you can save a lot of maintenance charges. The only maintenance costs that we see in electric vehicles are the battery packs, which get destroyed after a period of time, and obviously it will get destroyed. The only reason is that uh, the battery is the only part which is the most costliest in the electric vehicle. Now, if you compare, right, if you see your mobile phone batteries, they get deteriorated after a period of time. The same with electric vehicles as well, because they're using the same battery packs right now. That is the case. They have a range between 100 and 160 kilometers compared with 500 kilometers for most conventional vehicles. Yeah, so range is the main game over here. Though there are electricals which have their range much higher, but yeah, the range increases, the prices also increase of the vehicle. That is the case. But for most of the consumers, the range is well within the current commute range. Like you can at least use that electric vehicles to commute inside your cities, right? So I am presently a Barodian, right? I live in Baroda. So even if I want to travel from here to Ahmedabad, I think electric vehicle would work. That is for sure, because it's only 120 kilometers, and right now the vehicles are much available which we can use, right? Batteries can recharge overnight plug into a regular household of 120 volts or even faster than 240-volt outlet, similar to the type of outlet used for domestic clothes dryers, right? I think I would differentiate a bit from here, because thing is differentiate in the sense, as we can already see that for a 240 volt that we get in our houses, right? That is basically a one phase electricity, right? But for a faster charging and all of that, we do need a three-phase charger that will charge electric vehicles more safer and more convenient and more faster. That's what we can go for. Then installing a 240 watt outlet for electric vehicle costs approximately $2,400. Now, if we talk about the same in India, right, that will be costing something around 15 to 16,000 only for your port to get implemented. Because thing is that port usually differs a lot, because thing is you need to make a whole different electric connection. As I said, you need to have a three-phase charger. Many battery electric vehicle owners purchase a charging station for their home, which ranges in price from 600 to 1200. So what they will do is they will uh, like if I am having electric vehicle, if suppose Sahil has an electric vehicle, so if and we live in the same society, so what we'll do is we'll just implement a common charging point where all the nearby people can charge at this particular point, and we are the only owners of that. So we do not need to. We'll be like dividing it into different parts. So I think that will save our money as well. Now 400 volts rapid charging stations are now available in many locations. Right now, like if you want to charge a vehicle fast, right? Though three-phase charging are there, but the thing is that also three-phase charging will also take some time. Like it usually takes an overnight charging, even if you do that as well. If you want to travel 120 to 150 kilometers, in a four-wheeler. But if you want to go with the 400 volt rapid charging, we can definitely get those done in maximum of 3 to 4 hours, not more than that. And even if you are using some combinations, as we can see on the screen, that is Shadvo and combo connector combinations, we can get those 80% in just 30 minutes. In just 30 minutes. That is the case. So now, what is plug-in electric hybrid vehicle? A PHEV runs mostly on a battery that is recharged by plugging into power grid. It is also equipped with an internal combustion engine running on gasoline or diesel fuel that can recharge the battery or replace the electric drive when the battery is low or more power is required. So we usually abbreviate only hybrid electric vehicles, but actually electric vehicle is not only the part. There are two sub combinations in that as well. One is the plug-in hybrid electric vehicle, and one is a simple hybrid electric vehicle. Now hybrid, right? What does hybrid show it off? If we just show that in our minds, right? That hybrid means it's a combination of two or more than two, right? So yeah, so here it's, as we can see on the screen, as I already read the point, it's a combination of two different modes of power. The one is the battery one, and the second one is internal combustion engine, right? So we can use combination of both. And in this vehicle we can use both the powers at the moment of time. Like if supposingly if I'm driving a hill, right, so I can use both the powers, that is gasoline and a battery, both at the same time, so we can get more power. And supposingly if your fuel is exhausted or your battery power is exhausted, we can use any of the modes to drive your vehicle, so that your vehicle will not be stuck anywhere, right? So what should we know about PHVs? Like a basic concept. So original price, purchase price is comparable to similar vehicles operating in internal combustion alone, right? If you are using only an internal combustion engine, that will be costing you something around 6 lakh rupees, right? At current moment, if you're using just a simple car, a saloon car, right, that will be costing around 5 to 6 lakh rupees. But if you're using a combination of both of things in the same saloon car, it will be costing you something around 9 to 10 lakhs. I just given an easy example, right? There is a car which is Nexon, Tata Nexon, right? Tata Nexon usually ranges from 8 to 9 lakhs for internal combustion engine, and usually ranges from 13 to 14 lakhs for electric vehicles. So you can just imagine the difference between both of these things. The only reason between those is mode of change, right? That is the case. PHEVs offer readily available fuel from long distance driving and have a significantly increased range compared to battery electric vehicles. As I already said, you can use any of the modes if either of the mode is exhausted. Like if fuel is exhausted or if battery power is exhausted, you can use any of the modes, and you can at least get to a destination where you can use any of these modes. That is the case. Because PHEVs can be recharged on the public network as opposed to hybrid electric vehicles. They are often cheaper to run than hybrid electric vehicles. That is the only reason that if you use hybrid electric vehicles, you can, like, both the modes are differentiated, so you can use any of them, though the amount of savings depends on distance driven on electric motor alone. If the distance traveled before recharging is always less than the vehicle's range, it is electric only mode, right? The car never has to be refueled with a conventional vehicle. So that's what I said in the whole picture, that you can use any of the modes and you can just use it as per your convenience. Now hybrid electric vehicles. Now what exactly hybrid electric vehicles is like? Hybrid electric vehicle has complementary drive system. Complementary sense, it's a mix of two combinations. Like it, you can use only one mode, that is running through your conventional vehicle. You will just have some extra power that will run your vehicle. That is the case. So hybrid electric vehicles have complementary drive systems, a gasoline engine and a fuel tank, and an electric motor and battery controller and controls. The engine and the motor can simultaneously turn the transmission which powers the vehicles, where the hybrid electric vehicles differs from above of the two types, that is battery electric vehicles and like plug-in hybrid electric vehicles, is that hybrid electric vehicles cannot need to be recharged from the power grid. The energy comes directly from the gasoline and regenerative braking. That's what I'm trying to say. In PHEV, you need to charge it from the national grid or the grid that comes into our homes. But in hybrid electric vehicles, you can just use a combination of both of these things, and usually it will just increase your power of the conventional vehicle. So it will use a lesser fuel than a conventional one. So what should we know about hybrid electric vehicles? The original purchase price is comparable to similar vehicles operating on internal combustion engines. Hybrid electric vehicles have an advantage over BEVs because consumers are already comfortable with gas or diesel fuel vehicles, right? So these are higher chances of getting sell out in the market right now, and that's what the government is doing right now. We are getting a combination of both of this. You must be already knowing that, uh, right, a common vehicle Ertiga, right, you must be knowing that it has something written on the back, that is SHVS, that is smart hybrid electric vehicular system. So that's what is used there as well. It is not like using all of the 50-50%, but it's using 70-30%. Like 30% is generated from the regenerative braking, like when your vehicle is rolled and all of that. HEVs offer readily available fuel for long distance driving and have a significantly range compared to battery electric vehicles. As soon as the driver accelerates moderately, running entire electric motor lasts rarely more than 5 to 10 kilometers. So if you are driving around 70 kilometers, out of that, when your vehicle is rolling, right, sometimes what happens is we just leave our accelerator pedal and let the vehicle roll out so that we can save some extra fuel. That's what usually a human concept does have a mind. But it's actually not so. Your fuel will be consumed the same. It will just make a minute difference, right? So that's what is being said. you can just use them accordingly. Typically, the electric motor can also function as a generator driven by the engine to help recharge these batteries when electric power is not needed for driving the vehicle. Like, even if you don't have an electric vehicle, your vehicle can still run on the battery power. That's what even said. They are more expensive compared to PHEVs because they cannot be recharged on the public. Right, that's what we can say right now in terms of electric, they are more costly than compared to hybrid electric vehicles. The next slide, fuel cell electric vehicle. Now, before sharing this view on the screen, I would like to show you a video that will give you a clear insight about how exactly these vehicles are. Okay, so I'm just gonna share my screen. Just a second. Just a second. I'm just putting on that video. That is the only reason it's taking time.
Okay.
Yeah. So I think our concept is clear regarding that fuel cells, right? I'll just brief you about the same also. I'm just putting on that. Okay, one second. Yeah, so fuel cell electric vehicle. A fuel cell creates electricity from hydrogen and oxygen, as we have already seen, instead of storing and releasing the energy like battery, right? Because of this vehicle's efficiency and water-only emissions, some experts consider these vehicles to be the best electric vehicles, even though they are still in development phases and providing many changes. Since I think Toyota has started the concept, this concept was firstly implemented by Toyota, but still it is still into the like research phase. That is only like what exactly fuel cell vehicles are, which usually uses a combination of hydrogen, oxygen, and a battery. These are the three basic parts which are used for a fuel cell electric vehicle. It usually combines all the powers from hydrogen and oxygen, stores them into the battery, and then that form of energy is usually used to turn the vehicle. So it gives us a much more higher speed or much more efficiency. So what that will do is it will also boost up our range in terms of traveling. Like for a conventional electric vehicle, it will be presently going around 150 to 160 kilometers. But if we are using this fuel cell electric vehicles, I think 250 or 300 is less. Yes, that is the case. What should you know about FCEVs? Purchase price is high because the cost of a fuel cell is several times more expensive than the cost of a internal combustion engine. You guys can say that for a fuel cell vehicle, जितने में हम लोग एक लाइक एक हेक्टर ले लेंगे ना, उतने में सिर्फ इसका मेन इंटीग्रल पार्ट है. दैट्स व्हाट वी कैन से. ये सिर्फ फ्यूल सेल का इतना प्राइस रहता है टू द मार्केट. So it is much more costlier to us. Extracting hydrogen from a water molecule is an energy extensive process that generates greenhouse emissions if renewable energies are not used. That's why we use a combination of hydrogen and oxygen, so that we can convert those into a like useful combination, which usually does not affect the atmosphere. Because why are people running to electric vehicles? So that we can have lesser emissions and it becomes cheaper. और इसमें भी यही होगा, तो no one will take this vehicle as well. So that is the only reason that we use oxygen as well. So it will boost up the charging and also it will range up your vehicle. FCEVs are expected to be widespread in the market after the next few years. But I think so before that, we'll be getting the electric vehicles more implemented. Since February 2015, the fuel cell Tucson has been made for sale in Vancouver area, making Hyundai the first original equipment manufacturer to market a fuel cell vehicle. The concept bringer was Toyota, but to bring that vehicle into the market, it was Hyundai. Right. The Toyota Mirai was slated to follow suit, but was stalled due to the lack of infrastructure. As I said, initial phases, Toyota started this concept, right? They also wanted to make a vehicle because Toyota itself is a very big brand, right? But the thing is, due to this lack of infrastructure and all of that, they basically went out of this thing, and Hyundai took up the concept. The transportation infrastructure required to bring this fuel to stations is a challenge. The thing is, to differentiate water from hydrogen from water, it is risky as well, because even it can blast up to kilometers. That's what it can do. Then a clear layout about hybrid electric vehicles, plug-in hybrid electric vehicles, and battery electric vehicles. We'll start from this. 100% electricity from the grid, right? Electric motor, battery, and controller. These are the only parts, conventional parts that will be using. Now for PHEV, as I said, it's plug-in hybrid, right? So it will gasoline or electricity from the grid. That is what means we can use any of these modes to drive the vehicle. You can already see that. It's battery, gas is also driving the gasoline engine. Meantime, electric motor is also driving the wheels. So it is any of these modes. That's what we can see right now. In the hybrid electric vehicle, it's only gasoline engine which is driven by a battery and the gas. That is hydrogen gas, which is usually differentiated from H2. Motivation to embrace GV. Why people are more going towards GV? Domestic public policy goals, reduce dependence on foreign oil, job creation, economic growth. Right. As is a new concept, more people will be required to manufacture those vehicles because it also requires a human touch for this thing to go on. Global impact, Europe to mitigate climate change, China to balance growth and with pollution. Governments around the world would have allocated funding for clean technology. I think this one we can correlate with India. right? Because the thing is, as we can already see, India is already implementing a lot of policies and a lot of stipends as well, so that people can purchase electric vehicles. Energy independence, local energy reduce price volatility, it will get cheaper. Reduce export of dollars, particularly to unstable regions of the world. Reduce dependence on new key regions. That is roughly half the EU gases consumption from only three countries: Russia, Norway, and Algeria. These are the three basic countries which usually produces EU gases, which usually drives the vehicles in abroad. But right now, I think Gulf countries are also implementing that. Developing nations. Lower cost conventional vehicles support development goals, urban air pollution, rising oil imports to mean favor of electrification. China has stated its goal of reducing the carbon intensity of its economy. Right? China is slowly and steadily they are steadily implementing the electric vehicles. Lack of infrastructure grids is a huge factor. We don't have charging stations, right, in India. There are charging stations, but those are very few in some metro cities like Mumbai, Calcutta, and all of that. Climate change. These are some basic points that we already discussed in the first slide, that is greenhouse emissions and all of that, and the 1992 rule that states that we need to anyhow control this CO2 emissions, right? Because it accounts for almost of 50% of the energy. You can just see this economic reality of EV, like what has been going on, right? Electric, you can see the green one, the electric vehicles are a bit less range. PHEV going a bit higher. Hybrid is more preferred, and IC is the most preferred one right now. The thing is, this bar is going straight since a long period of time. Like you can say 10 years or about more than that, in fact. Right. People are implementing more towards hybrid electric vehicles because the thing is, it can save your fuel. The SH-based technology from Maruti Suzuki right now. That uses a hybrid, you can say hybrid technology. And at the end, ICE. We can already see that in terms of picture. Like ICE, that is any of the conventional vehicles that we have. The present technology of PHEV, that is the second thing that is going on right now into the world. The third thing, that is PHEV, that is combination of both the things. That is, we can use either of the power sources. And the last one is electric vehicles. Like there are very less people who are just using electric vehicles, right? Electric economics will favor electrification. Electric vehicles emit zero tailpipe emissions at the point of use. The carbon footprint of electric vehicles is approximately 30% better than that of the conventional vehicles. Even when the electricity is used and produced by a coal-fired station, total cost of ownership will become increasingly favorable as the prices of fuel rises in the future. Current global economic conditions will drive how quickly fuel prices begin to appreciably rise and influence the TCOs of various models. Right. As of now, the people are turning somewhat towards electric vehicles. I can see that Ether. Right now, you must be seeing in the advertisements that Ether is coming into the picture. Right. But is the cost higher? That is the only reason that people are not taking it. Now, electric versus gasoline. No tailpipe emissions in electric vehicles, utility company, 100 plus mile range, hours to recharge, 2 cents per mile. That is the case. Is greenhouse emissions, gases, OPEC, that is, you can say that pollution same as to the factories and all of that. Range is high compared to electric vehicles. Only you can say seconds to refuel the vehicle. 12 cents per mile, or even more than that right now. 12 cents in the sense dollar, and lesser than dollar is known as cents. That's what is the case. So at cents a bit higher. Then electric is an example of electric versus gasoline. If you're talking about Honda Civic, right? It's a gasoline vehicle. It will like cost you 86 miles per gallon, right? Toyota Prius, which is a hybrid electric vehicle, it's 46 miles per gallon. Chevy Volt, which is a plug-in electric vehicle, is a combination of both. You can just see the difference between these three, right? How much difference is it making from the conventional vehicle? It's 86 and 40. Like what difference does it make? Seriously. And Tesla Roadster, that is a different thing. It's obviously a far, you can say, more convenient vehicle. That is 227 miles per charge. That is the only reason that Tesla vehicles are much more, you can say, costly. Benefits. I think benefits are the same. Like I think I will not waste much time over here because these are the same points that we are seeing right now. Right. Drawbacks. Electric vehicles have a limited range due to battery size and construction. That is a basic point why people are not preferring electric vehicles. Charging a high voltage battery can take a longer time depending on the battery charge and power source. The network of electric charging station is sparse, and if the destination is beyond the range of electric vehicle, the driver will have to plan the journey. Supposedly if I want to go from here to Udaipur, so I will have to plan a journey that how should I go with electric vehicle by charging at different points. Because the thing is, maximum I can drive 150 to 160 if I'm using a vehicle like Nexon to drive from here. That's what is the case. Comparison of EVs. These are all the models that we have already seen in the last picture as well. But yeah, just a clear picture it was, so I just put it up here. That is the case. EVs varying in electric performance. Right. Micro hybrid provides a lesser range, provides a higher range. Mild hybrid a bit lesser than the ones. Well, we can say that plug-in hybrid electricals are the ones which provides a very less range in terms of speed. That is the case. Full hybrid, it's a bit less. Mild hybrid and micro hybrid. I spoke about a vehicle right now, right? The Maruti Suzuki one. It's a mild hybrid. Right? It's not a full hybrid. It's a mild hybrid. It's SH-based technology. It's smart hybrid. That is the case. Now we'll just talk about some integral parts of an electric vehicle. Electric battery, right? Now electric battery basically those are of many types depending on what type of we are using. Like lead acid battery, nickel metal hydride battery, lithium ion battery, lithium polymer battery, lithium iron phosphate battery as well. But the most used one is the lithium ion battery right now into the market, because these two are bit higher. There are some important terms, battery terms, that is state of charge, SOC, battery capacity expressed as a percentage of maximum battery capacity, like in terms of volts, we can say that. Depth of discharge, like how much the vehicle is getting discharged and running. Capacity, how much the battery can store the battery with the specific current with from 100% state of charge. The energy, like how much battery power is it using to drive the vehicles. Specific energy, the total watts per unit mass, like what type of weight the vehicle is putting on. Specific power, maximum power that the battery can provide per unit, function of internal resistance of battery. Now, I'll just provide you two comparisons which are the most going on right now. Nickel metal hydride batteries and lithium ion batteries are the best for EVs today, as I said. This is an example of a metal hydride battery, high specific power, long cycle life, but yeah, the cost of this is much more higher. I'll just give you an example. I took a 48-volt battery for only an electric two-wheeler. It costed me something around 25,000. So you can just imagine how much this would cost, because metal hydride and nickel especially, it is much costly. Lithium ion, higher cell voltage, higher specific power, higher specific energy, low self discharge, higher initial cost, low cycle life as compared to metal hydride, and need for control and protection. For this battery, we do need a separate management system. Now, this system. What does this system do? I'll just give you a short insight. I'll just not read the whole the same thing again. But yeah, I'll just give you briefly these 2 points, which usually states that what exactly battery management system is. Battery management system is a system which usually prevents your electric vehicle from getting short circuited. You can share heating protection, automatic cutoff, over voltage, under voltage, because in case a lot of parameters are taking place when you're using electric vehicle, and it obviously can affect your battery life, and even it can cause an electric vehicle to catch on fire as well, right? So that's what we can say it right now. Battery management system is an electronic system that manages a rechargeable battery such by protecting the battery from operating outside its safer operating area. Like these are the points. These are the safer operating points. Calculating secondary data, reporting its data, controlling its environment, authenticating it, and balancing it. Like how much and what to deliver, that is decided by BMS. That is the case. The electric motors of EVs, like commutator motor, commutator motors or synchronous motor. This is a commutator or synchronous motor, right? Then there are induction motors. There are hub motors as well. Yeah, for electric two-wheelers, mostly we can say that hub motors are mostly being used, because thing is, if you are using a DC motor, or you can say brush one motor, it will usually result into a chain drive, which will result into power loss. So that is the only reason people usually prefer like the hub motor for electric two-wheelers. for electric vehicles or electric cars, we are using differential and all of that, so that will obviously save the battery and all that. Electric motor comparison: induction motor, switch reluctance, PM brushless DC motor, permanent magnet, brushless DC motor, and brush DC motor. The most used one right now is the PM, that is permanent magnet brushless DC motor. The only reason that is long lifespan, least rotor heat generated, low maintenance, and high peak efficiency. Though it has some disadvantages like higher initial cost, requires a controller, poor high speed capability, and adjustable magnetic field. These are the only disadvantages. Other than that, I think this would be the best option for electric vehicle. Now, I think we have covered all the points regarding the common electric vehicle. I'll just take you about my project, what I did when I was a part of a team Advitya. So yeah, finally to Advitya's Ashray. Now we gave this name to the team. Advitya means it usually correlates with us with Hindi abbreviation like Advitya. जिसका कोई द्वितीय नहीं, Advitya. And Ashray because there are ashes of problems of pollution, and to provide that we are providing a ray of hope. So that's what we can say, Ash Ray. Now, actually, this vehicle was basically made for an competition which was based out at South India. This which was conducted by SAE India Southern Section, and for that competition, almost 60 plus teams were participating from all across India. Right, and it was basically it provided us basically some rules that we need to go on. Electric propel, single seated that could carry 95% versatile mail. Battery 48 volt lithium ion batteries. BLDC AC/DC motor is 1 kilowatt or 25% or more than that. Vehicle maximum speed of only 35 kilometers, because if we go about 35 kilometers, we need to get those vehicle registered into the RTO. That is a rule that we do not need to register vehicle if it is less than 35. Frame tabular lightweight. Suspensions in the front and rear that should be telescopic. All parts should be custom designed and built. Braking system should meet the CMVR. Now, what is CMVR? CMVR is basically the term which is usually related with the braking system, like a regulating document, you can say that. Front wheel steer only. All the electric components should be protected from water and dust. Like to protect this is basically you can like say that no short circuit happens in the same. Right. So this is how it started. Now, first of all, coming to the battery, like we already have seen that they provided us that we should use a frame that is tabular lightweight. So that's what we did. We basically made some prototype with the help of plastic pipes in the initial days, and then based on that, we made this frame, which usually considered of a chromoly material. For that also, we like compared a lot of other materials such like the aluminum, MSIS, and chromoly. But we mostly preferred chromoly, depending on the points that we have given, like availability, weldability, workability, machinability. You can see that it is going much higher than compared to both of these, like 31 and 21. You can just say that it's a minute difference, but MSIS is much more costly than compared to chromoly, though it's a lightweight as well. Right, and basically we used hollow pipes rather than using the solid pipes. The only motive behind using that was that it will have a higher polar of moment of inertia as compared to the like solid ones. That is the case, and they're actually light in weight as well. Right, then body. Talking about the body, like in the initial days, we thought that we will basically use FRP, that is fiber reinforced plastic, but that created a problem for us to basically implement it. The only reason that was how to mold those things. The thing is, molding was a big issue. That is why we mostly went for aluminum sheet, and we actually had some aluminum sheet things as well. Like it has adhesive strength, elongation of resiliency, and help absorb like equipment vibrations. You can just use an rubber piping, which usually prevents from vibrations and all of that. These are competitive lightweight as compared to FRP, because FRP are a bit thicker and they are much more heavier in weight as compared to FRP. Easier to handle, significant free design freedom. You can just mold the way you want to, and low cost. Now, battery report. Basically, we were told to use lithium-ion batteries. That's what we did. But yeah, just for a comparison, I put these two things. Like if we use a lead-acid battery or a gel-type battery into electric two-wheelers, it will provide only 350 charging cycles. Like what is charging cycle now? Charging cycle is usually defined as, suppose if you are charging your phone, right? So if you are charging it to up to 100% and then removing it off, that is known as one charging cycle. So in this, it was only 350 charging cycles, and for lithium-ion battery, it was more than 1,000 cycles. So that is the reason that people are preferring more lithium-ion batteries. So these are some advantages of relatively low self-discharge, low maintenance. It delivers strong overall performance, right? Though heating rate is much more less than compared to the cathode powders and all of that, right? No requirement for priming, right? This is the thing. Now, sorry, I just missed this part. What are the better specifications that we use? Now, basically, every battery consists of a battery cells. Like if you're talking about lithium-ion battery, it consists of battery cells, which usually is defined in the terms of C rating. I'm just clearing it. It's known as C rating. That is the case. So you are using the C rating battery, and every like if you are using a battery, like usually consists of different cells. So yeah, we are using a 48-volt lithium-ion battery. The battery capacity was 24 ampere hour. The battery efficiency was up to 80%. The nominal wall cell voltage. Now it was usually consisting more battery cells, so that was around 3.7 volts and 3.7 divided by 1,000. So those are the number of cells that we are using in this battery, and we actually use this battery, that is the ERX one, which is the local manufacturer of from Ahmedabad. Battery dimensions and number of life cycles that are more than 1,000. Then the motor report. What did we use? We used the BLDC hub motor. The reasons behind using them in electric two-wheeler was this: that better speed, high versus torque characteristics, high dynamic performance, high efficiency, long operating life due to lack of electric and frictional losses, noiseless operations, and high speed ranges. Right. Specifications of the motor as shown in the table. Construction brush test DC. Rated voltage is 48 volt. Rated power is 1,000 volt. Weight was around 9 kg. Efficiency was up to 80%, though we had it was not exactly 80, it was even less than that. But yeah, the company claimed it to be 80%, but yes, we had something around 70 to 75% of the efficiency because we even tested it. Rim size, that is 10 inch and 316, you can say that. Tire size was 360. RPM at no load was 400 to 1600 RPM. Torque was 37 Newton meter. Maximum torque was something around, you can say that 72 Newton motor volt. And maximum carrying capacity is 200 kgs. Though it is written as 200 kgs, but I can just assure you for one thing: we had a person in our team which was almost 6 feet to 6'2". His height was 6'2", and he was weighting around 150 kgs. And there was one more person in the team who was like weighting around 100 kgs as well. So both those persons sat on our vehicle and we tested it actually. So we have just written as 200 kgs, but it's in fact more than that, like around 250 kgs. The controller report. Now, I have not described much about it because we did not have the exact specification because it's a bit confidential right now because we are already working on a startup, right? So, regenerative type controller. Now, what exactly a regenerative type controller is? See, whenever we are going on a slope, right, what usually normal people do is they just press their clutch and let the vehicle roll down. That's what we people do in the conventional vehicles, and they think that it actually saves some food, but it's actually not that so. But in electric vehicles, it definitely is. The thing is, if you roll your vehicle continuously, and if you are like restoring some power, which is usually turns by the battery, it will usually charge your battery as well, because it's like mechanical energy getting converted into kinetic and kinetic into electrical. That's what we're making it of right now. So regenerative controller gives a motor the capability to act as a generator while in operation. Energy is regenerated during the braking process and even rolling process as well. And the output of the battery is supplied to an electric roll. Regenerative DC drives are often called as regen drives for short. Now these are some circuit diagrams which basically differentiates on what type of vehicles we are using. But yeah, some basic parts of an electric circuit are Hall sensors, BLDC motor, some fuses, some fuse over here as well. So yeah, this is all about it. Then signal lights. We are not show off battery over here because it's an integral part. We already know that battery is there is for sure. But yeah, battery would be there. That is for sure. The charging circuit diagram. How is the charger? Because the thing is, we had this charger which was basically I would have showed it off because the thing is it's a bit confidential because since we have remodified it, we have already applied for patent as well. Now, how we initially started the process? Like in the initial days, we made this frame, we tested it in ANSYS, and then we started like converting those into SolidWorks and all of that. And this whole design procedure is done on the basis of SolidWorks, which is a software, and ANSYS. You can just see this red portion where you can just see the stress and strain and all of that. In the initial days when we went the vehicle, I can just share this thing over to you. We had a factor of safety which was very high. Actually, for electric, for any two-wheeler, the factor of safety should not be more than 6. That is a particularly a fixed unit. It was even more than that. Then we met this weldability and all of that. Then we converted into this. This is how we painted and all of that. Then the body molding and all of that. That's what we did. Then as soon as we received this electric circuit, even if you can say that way, though we bought this ready, but we still modified into it and we provided a battery voltage, you can say unit as well, that we can say exactly what type of battery voltage it is showing. That's what we did. This is all the priming and all of that. That's what we did for the electric two-wheeler. At the end, the fitting goes into the picture, implemented to this, and at the end the graphics. That's what we did. Actually, saying it this way, people can usually say that it's an FRP plastic, but it's not actually an FRP. It's actually aluminum sheets that we have molded it off. Now, what were the features that we were having in our electric two-wheelers? Actually, on the basis of that only, we won the competition. Project DRL, high braking, that is electric braking. We provided that as well. Like you can just stop your vehicle through disc braking as well, but still we provided electric braking as well, which will usually reverse the direction of the motor and it will stop your vehicle. App-based GPS tracking system. Even supposingly if my vehicle is stored from a particular location, so I can just look up the location in my vehicle, and it was at a confidential point. So we can just see that in the vehicle that where my vehicle is roaming around, and I can just stop my vehicle right hand, and my vehicle will be locked at that moment of time. Parking switch mode, warning lights in the speedometer, automatic headlamp, actual voltage display in the that way, reverse assist. Now we had made this electric vehicle which can also run in the reverse as well. The motive of providing this in reverse was like we obviously know that when we are going to a steep slope, right, and if we want to move our vehicle into the backwards, we will usually require a lot of energy to move that. That is the only reason why I provided this mode, which will by the switching, which will reverse the direction of the motor, and we can run the vehicle in the reverse direction as well. SATs indication, which is a common point, I guess, and a toggle switch for charging and like riding mode. That's what we provided it off. Now, what were the achievements that we did? Now, we competed with 60 plus teams from India and won the overall first prize for overall performance and best maneuverability, with cash prize of 75,000 and 15,000 respectively by SA India Southern Section. That's what we did. Here is my team that we were off. This is the captain and all of that. Yeah, what is the fame that we usually got of with the same? It's actually 7 plus press interview, but I think we in fact did more than that. We usually went for almost 15 to 16 press interviews and newses as well. You can just see right over here, right? Even the Times of India was also there, but I was never able to paste it because I'm not having the copy of that. We also participated in the Makers Fest, which was conducted by MS University. We also got Gaurav Puraskar from CVM because we were the only team from Gujarat who participated, and we were the overall winners for the whole competition. So yeah, that was it, all about it. So before ending this, I would just like to show you a video that usually shows that how we made the electric vehicle. Just a second. So yeah, that was all about it. And if you're talking about the same, like this electric vehicle, the main pitching point of this electric vehicle was like we can charge this vehicle at the cost of only 8 rupees, and we can run this vehicle up to a range of 72 kilometers. And that was tested by us itself. It's a testing that we did manually, and we were even appreciated by the people who came from Royal Enfield and all of that. And we are actually working on a startup also right now. So yeah, that is all about me. And yeah, I think Sahil sir, we are done with the same.
Okay, Vises, and thank you so much for such an informative session and for your valuable time. Vises, just do one thing.
Sure,
Present your screen and just on your video. I have to take one screenshot of that.
sure, sure. I can do that. Yeah. Just a second. Huh? I'm just taking
Okay,
that
okay,
over.
okay.
Yeah. I think I'll just keep this one, and yeah, I'm coming on screen as well. Just a second.
Okay, Vises. So thank you once again
Pleasure
for
was all
such an
mine.
valuable time.
Pleasure was all
And
mine, in fact.
okay, so we will end this session here. Okay.
Yeah, sure.
Okay. Thank you.
All right. Thank you. Yeah.
Thank
Bye.
you.